Continuing with Unit 5, name reaction. The next reaction is Claisen-Schmidt condensation. So as the name indicates, it's a type of condensation reaction. So let's see the basic scheme first. It's a type of crossed aldol condensation where we take two different types of carbonyl compounds. So both the reactants will carry the carbonyl functional group. So what's different between them? Okay, so the first compound must be an aldehyde, and this aldehyde should be devoid of an alpha hydrogen. So an aldehyde without alpha hydrogen. For example, benzaldehyde. Okay, so this is the carbonyl compound, carbonyl functional group. The carbon next to that is called as the alpha carbon, and the hydrogen present on such carbons are called as alpha hydrogen. Now for this compound we can see that the alpha carbon does not carry any hydrogen, is devoid of hydrogen. Okay, now don't get confused with this hydrogen. The hydrogen here is not an alpha hydrogen, it is aldehydic hydrogen. It is directly connected to the carbonyl functional group and not connected to the alpha carbon. So this is not an example of alpha hydrogen, this would be an aldehydic hydrogen. Okay, and this is the alpha carbon. Hydrogen present on the alpha carbon are called as alpha hydrogen. In this particular case of benzaldehyde, we can see that the alpha hydrogen does not carry alpha carbon does not carry any hydrogen. So this would be an example of an aldehyde without alpha hydrogen. Now the second compound that enters the reaction. The second compound is again a carbonyl compound, but it can be either an aldehyde or a ketone. Either one of them. But whether an aldehyde or a ketone, this compound must contain an alpha hydrogen. So for example, the simplest of the ketones, acetone. So again, carbonyl, alpha carbon, and this time you can see that the alpha carbon carries hydrogen. So there are actually 3 alpha hydrogen present on this. Okay. Another example would be of an aldehyde, say acetaldehyde. So again, carbonyl, alpha carbon, and on the alpha carbon 3 hydrogens are present. So this compound also contains alpha hydrogen. Again, this is not an alpha hydrogen. This is the aldehydic hydrogen. So don't get confused between these two. Okay. So now we have our reactants, an aldehyde without alpha hydrogen and a ketone or an aldehyde containing an alpha hydrogen. Now these two compounds will react with each other in presence of a basic medium. So you can use either sodium hydroxide or maybe sodium ethoxide to provide the basic medium necessary for the reaction to proceed. And these two will react to form a product which is alpha beta unsaturated carbonyl compound. Now what does this mean? It means the product contains the carbonyl functional group and it also carries unsaturation between the alpha and beta carbon atoms. So if this is the carbonyl, the carbon next to that is alpha and the one next to that is called as beta carbon. And between the alpha and beta carbon, unsaturation or double bond will be present. And this compound is called as alpha beta unsaturated carbonyl. So I hope the basic scheme is clear. You take an aldehyde without hydrogen and make it react with a ketone or an aldehyde containing an alpha hydrogen. Reaction proceeds in basic medium to give you the product which is alpha beta unsaturated carbonyl compound. Now let's have a look at the reaction. So the first compound is aldehyde without the alpha hydrogen and we are taking benzaldehyde. And the second one, I'm choosing a ketone for the reaction. So let's go with acetone. And we can see that the second compound contains alpha hydrogen. Now these two will react with each other in presence of a basic medium, and it will form the product. So what is a product? So I'm going to give you a tip to form the product. Okay. Instead of writing it like this, I can actually draw it like this. Okay. I draw CH and double bond O. Okay. And this side I can draw this compound acetone. So I'm going to draw acetone like this. CH and H2. So 2 plus 1, 3 hydrogens, CH3. And you can draw the remaining compound as it is. Now is condensation. So one molecule of water will be removed. Water is H2O. So O comes from benzaldehyde and H2 comes from the ketone. Now these two will react with each other, okay, and there will be removal of water, which means we need 2 alpha hydrogens minimum here. Okay. So now what will happen, this CH will be connected to this CH with a double bond and the water in between will be removed. So I'll write the benzene ring CH, I'll put a double bond and then I start writing from here because this is removed. This will not be present in the final compound. Okay. So CH and then C double bond O, CH3. As you can see, this is a carbonyl containing compound. So this is the functional group alpha, beta, and between the alpha and beta carbon we see a unsaturation or a double bond. So this is example of alpha, beta, unsaturated carbonyl compound. Okay, it's called as benzyl acetone. So I hope the reaction is clear. Now let's have a look. Let's have a look at another reaction with different set of compounds. Okay. So again, if I take benzaldehyde and this time if I make it react with acetaldehyde. So again, how do I write the reaction? Instead of writing as H3, I can write it H2, one more H which is connected to the carbon, and CO, and okay, so this is acetaldehyde, another way of writing acetaldehyde. Now this will be removed. So minus water, and then CH double bond C will be connected to this CH, and you can write the product. CH double bond, now this CH, C double bond O, and this H. Okay, so even here you can see carbonyl. The carbon next to that is alpha, the one next to that is beta, and we can see an unsaturation present between alpha and beta carbon. So this again is an example of alpha, beta, unsaturated carbonyl. Okay, so I hope you get an idea of how to guess the product, how to make them react. It's very simple. Kick off a water molecule. Oxygen is removed from aldehyde and hydrogens are removed from the alpha hydrogen containing compound, and you club them together with the help of a double bond, and there you have it, your product. Okay, now let's have a look at the mechanism. So I'm going to teach mechanism with the help of the first set of starting material, that is benzaldehyde plus acetone. Okay, so how does this reaction proceed? This reaction actually involves 3 steps. Step number 1 is generation of nucleophile. Step number 2 is nucleophilic attack on carbonyl of aldehyde. And step number 3 is dehydration. And this step introduces unsaturation or double bond. Okay, so let's have the look at the mechanism one by one. So step number 1, generation of nucleophile. So nucleophile which is generated is actually the enolate anion. For this step we need the alpha hydrogen containing compound. So in our reaction, acetone is the alpha hydrogen containing compound. So I take acetone and put it in the basic medium. Now look at the structure of acetone. So this is carbonyl and there are 2 adjacent carbons. Now these carbons are attached to carbonyl. We all know that carbonyl is an electronegative group. It will exert minus I effect. So this carbonyl is going to remove the electron density or pull the electron density away from the adjacent carbons, because of which these carbons, the adjacent carbons, will become electron deficient, and by the effect the hydrogens attached to them will also become electron deficient. So we can see that these hydrogens are electron deficient, and they are, because of this presence of the carbonyl group, these hydrogens will attain a slight acidic character. So these alpha hydrogens are actually slightly acidic. Now when you take an acidic compound and put it in the basic medium, what happens? Acid and base will react. Okay, so the generation of the nucleophile is actually an acid-base mechanism. So I'm just going to make mind modification here so that you can understand the mechanism properly. Okay, so I'm going to write this as CH2 and I'm going to draw 1 hydrogen separately. Now the base comes, which is OH minus. NaOH will dissociate to give you OH minus, and this OH minus has got a lone pair. Now by definition, bases are electron donors. So the OH minus can donate the lone pair to this H. Now this H is acidic. It means it will be removed in the form of H plus. So what happens is that the base comes and it abstracts the proton. So this OH is going to form a bond with this H, and this bond formation requires 1 pair of electron, and the electron pair is donated by OH minus. So this lone pair is converted into a bond. Now this H is leaving as H plus. It means it is going to leave its electron behind. So if you do see this bond, there are 2 electrons. One belongs to carbon, the other one belongs to hydrogen. But hydrogen is not going away with hydrogen, its electron. It's not going away as an hydride. It is leaving as H plus. So both the electrons remain here, and once H plus is removed, this electron will sit as a lone pair on carbon. So this is what is happening. after the attack of the base, one hydrogen will be removed from CH3. So CH3 gets converted into CH2 plus this bond is converted into lone pair and it sits on the carbon. And you have the remaining thing. Now carbon has one additional electron, so it gains a negative charge. And if you see, this is actually a nucleophile. Nucleophiles are electron-rich compounds. So there, by the attack of the base on the alpha hydrogen containing compound, we have generated the nucleophile. Now the nucleophile can show resonance, wherein this lone pair can actually shift here and this will shift here. Now bachcho, please remember, you either draw the lone pair or draw the negative charge. We don't do both. So the negative charge, which is also the lone pair, it shifts here. Iska matlab this double bond, this lone pair is forming a double bond here. Then this carbon will be forming 1, 2, 3, 4, 5 bonds. It means the pi bond has to shift and it sits on the oxygen. So the resonating structure would look like this. A double bond here. And oxygen has gained an additional electron. Okay. This is also the nucleophile. Okay. So just another resonating structure of this. So I hope the generation of nucleophile is clear. Now this nucleophile will enter step number 2, which is attack of nucleophile on carbonyl carbon of benzaldehyde. Okay, so let me draw both the compounds properly. Okay, this is my benzaldehyde and you have the nucleophile generated in the previous step. Now this nucleophile can attack. Okay, so nucleophile is electron rich. It can attack electron poor species. So look at this benzaldehyde. Again you see the carbonyl. So carbonyl is a bond between carbon and oxygen, where oxygen is more electronegative. So it's going to withdraw the electron density away from carbon. So the presence of this oxygen makes the carbonyl carbon electron deficient. So it's actually this carbon has electron deficient and it gains a slightly positive charge. Now the electron rich species will be attracted towards electron deficient part, center of the molecule. So this nucleophile can actually attack the carbonyl carbon. And that's what happens in the next step. So the nucleophile goes and it attacks here. So when I show this arrow, what do I mean? That this lone pair on the carbon is going to get converted into a single bond between this carbon and this carbon. So ye carbon of acetone and this carbon of the benzaldehyde are going to form a bond with each other. Now if that happens, this carbonyl carbon will have 5 bonds. So what will happen? The pi bond of the carbonyl will shift and it will sit as a lone pair on the oxygen. So that's my step. Benzaldehyde, carbonyl. Now this carbonyl has got one hydrogen and it is attached to the acetone, CH2 of the nucleophile, C double bond O, CH3. Okay, and this was a double bond, but now it is converted into single bond and oxygen gains a negative charge. Okay, now in your medium you will also have plenty of water molecule. So this O minus can abstract a proton from the water molecule. So it gains an H plus. And now this will get converted into So this is the intermediate after attack of the nucleophile on the carbonyl carbon. Now pay attention to the this intermediate. The central methylene CH2, I can actually write it in this way. carbon and 2 hydrogens. Now this methylene is also slightly acidic in nature. Why? Because it is also attached to a carbonyl functional group here. Okay, and this carbonyl functional group is going to exert a minus I effect, and that makes this CH2 kind of acidic. So these protons also have a slightly acidic nature. Fine. Now this compound which is formed is going to enter step number 3. What is step number 3? Dehydration. Okay, so I think I'll show step number 3 right here on this slide. So step number 3 is dehydration. So loss of water molecule will introduce a double bond in this structure. Okay, so I'm going to draw this intermediate properly so that you can understand this step. CHOH is what we formed. Then you have C. Then you have 2 hydrogens attached to this carbon, which are slightly acidic in nature, and you have a CH3. Okay. Now, water removal में this OH and this H are lost. So OH from the aldehyde part and H from the keto part or the alpha hydrogen component part. So this carbon will lose OH and this carbon will lose H, and the net loss H plus OH will be net loss of water, and this loss will introduce a double bond here between these 2 carbon. So the product will be now I'm drawing this carbon. This carbon initially had 2 hydrogen, but 1 is lost. So in the final product, this carbon will carry only 1 hydrogen. So I've drawn that hydrogen. And then this is connected to COCH3. And there you have it, your compound. So carbonyl carbon, the one next to that is alpha, the one next to that is beta. This is also alpha, no doubt about it. Okay, but you don't have a beta here. Here you have alpha, then you have beta, and between the alpha and beta you have a double bond. So this is an example of okay. So I could show you the mechanism of water removal, but we have done that many times in other synthesis, so it's not really required. So long as you understand that the last step is dehydration, where OH and OH will be removed and there will be introduction of a double bond, and that's how you form your final compound. So I hope this is clear. Okay.